Hi.
Oi! So they give access to their job portal, GeeksforGeeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, GeeksforGeeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi! Are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, hello, sir from the internet. Please, those who are watching me, I would request you all to kindly do a +1 in the chat box so as to give your confirmation that you are watching, and this will keep the session interactive. And yeah, let me share my whiteboard scripting with dynamic programming very soon. Let's wait for a couple more minutes so that others could join. Yeah, so please confirmation in the chat box. Okay, so that we can very quickly start. and tabulation will be given to you as a homework. Okay. So yeah, let's get started then, so that I can get to know your names. I am not audible. Is that so? I think. Am I properly audible? I suppose the mic is properly working in my case. Just give me a confirmation. Divakar, can I please have a confirmation from your end? So yeah, so those who are watching me, I would request you all to kindly do a +1 in the chat box, and today we'll be studying about longest common substring. We will be studying about subset sum partition and equal sum partition. Okay, yeah. So let us begin then. Okay, little bit stroking your voice. Okay, there may be a slight connectivity issue, but I think it will get better once the session progresses. So, Divakar, I would request you to kindly stay till the very end of the session. And yeah, so do you know about the longest common substring problem? So tell me, do you have any idea about how? Yeah, so let us have a look into the concept of longest common substring then. Okay, so basically, what happens in longest common substring is that we have already seen the variation of the problem involving longest common subsequence. Sequence and a substring is that substring is always contiguous. Okay, so a substring, it is always, for example, A, B, C, J, K, J, K, L, B, and A, C, J, K, P. Okay, suppose this is string 1 and this is string 2. The length of the string 1 is n, which is equal to 1, 2, 3, 4, 5, 6. N is equal to 7. And length of the string B is equal to m, which is equal to 5. Okay, so basically you are given two strings of length 7 and 5. A substring is basically something which is contiguous in nature and it is present in both S1 and S2. Okay, so Divakar, I would request you to kindly stay with me. So this session won't be very long. It will be around 30 to 35 minutes or max at 40 minutes. But I will be discussing two very important questions on the topics of dynamic programming, and it will certainly help you. So the longest common substring in this case would be CJK. Okay, so let me just mention CJ and K. Why CJK? So let me write it with the yellow pen. So CJK is basically this and CJK is basically this. Okay, so let me mention. So basically, CJK is a substring of the second string as well, and CJK is also a substring of the first string. And it happens that the length is equal to 3, which is also the longest possible. Okay, so that is the reason the answer should be 3. So now we are given two string, and we are asked to find whether what is the longest common substring, the length of the longest common substring. Okay, so the first of all, since we have done in the previous session, the concept requires us to formulate a brute force recursion approach. Okay, so the step one is writing a brute force recursion approach. And how we will do that? We've already seen in previous session when we did the problem of longest common subsequence, how we were generating and constructing and implementing the function. So we will be following the exact same approach here also, but there will be slight modification because we are only allowed to take contiguous subsegments only. So let us say I declare a function called int f, and this function takes two variable. First is index 1. Okay, so just a minute. So in this case, I will be discussing both the recursion approach as well as the tabulation approach. Okay, so let us see then. Okay, so first I will be discussing the recursion approach, and then I will be discussing the tabulation approach. So let us see that I have created a function called int f, and this function takes two variable. First is index 1, and then the tabulation approach. So tabulation is nothing but it is very simple. First of all, so we will be declaring a DP array. Okay, to two-dimensional DP array. Why two-dimensional DP array? Because this DP array contains two changing parameters. It is the index 1 and the index 2. So index 1 is used to iterate on the string 1, and index 2 will be used to iterate on the string 2. So we will be constructing a DP table first of all. Okay, so how will the DP table look like? Okay, so let us say that I construct a DP table of size n into m. So let's say this is equal to 0, 1, 2, 3 up to m, and this is cross m. So n is for s1 and m is for s2. Okay, so now what exactly I mean by this DP table I will be showing you right now. Okay, so let me just draw a bit of the lines. Okay, so initially let us say that I am filling the DP table with 0. All the values are 0 in this DP table. Okay, so let me just fill all the values with 0. Okay, so now what we are doing basically, we are iterating from for I is equal to 1 to n. Okay, because I will be going from 1 to n, and we are again iterating for j is equal to 1 to m. So basically I am iterating on this DP table. So this I comma j are iterating on this DP array. Okay, this DP array, and not on the string. Okay, so but our string will follow 0 based indexing, and our DP table is following 1 based indexing. So in that case, what will happen? So in that case, what will happen basically is that, so first of all, we will check that whether this character present in that particular position is equal to 1 or not. Which means that if the character present at the string 1, which is equal to s1 of I minus 1, is equal or not. Okay, so if it is equal, okay, if it is equal to s2 of j minus 1, so if both are equal, it means that it belongs to a part of the substring. Okay, it is a valid substring. So in that case, what I will do, right, int val is equal to 1 plus dp of I minus 1 into j minus 1. So 1 because we are just increasing the value of the space by 1. And then finally what we will do, we will write dp of I comma j is equal to value, and then we will also update value, or in fact answer will be the maximum of all possible values. So answer will be max of answer comma val. So this is what we will do when we are given this question. So answer will be equal to 0. And let's say if in case where they are not matching, it means that particular cannot be a substring. So in that case, I will just write dp of I comma j is equal to 0. Okay. So this is how the tabulation form of the progress tabulation form concept will progress. Now, tell me the time and space complexity of this approach. Anyone? So I see students who have joined my session. I would request you all to kindly do a plus one in the chat box. And you can also tell me the time complexity and the space complexity of the tabulation approach for finding the longest common substring. Okay. So yeah. So in terms of n and m, so n is the length of the first substring and m is the length of the second substring. So the time complexity and the space complexity will be anyone? So Divakar, you can try. So I would request everyone to kindly keep the session interactive because so Divakar, tell me, are you there? Or if not Divakar, anyone else? I see a few people present on my streaming session right now. Yeah. So before I proceed with the session, I would like to mention about a particular course called Complete Interview Preparation. In fact, this particular course you will find on the GFG platform. You will also find it in the description of this video. So if you're preparing for your upcoming interviews, you can definitely check that course out because that particular course contains all the necessary topics and concepts which are very frequently asked in interview these days. And it will also give you a very structured preparation for your interviews. So I would request you all to definitely check that course out. It will most certainly be helpful. So Divakar, you are telling n square. So well, it will not be n square because in fact you're correct because it will be a quadratic time complexity. But I am asking you in terms of n and m. So it's not necessary that the length of the second string will also be equal to n. So in that case, can you give me a proper answer? If not Divakar, anyone is free to write in the chat box what will be the time complexity and the space complexity of this particular approach. Then I will do a dry run with the same example that I took. Okay. Anyone? Let's wait for few seconds, then I will tell you the answer. Yeah, so basically the answer would be that the time complexity is of big O of n into m because as you can see we are running a loop. The outer loop is running n times and the inner loop is running m times. So the proper way of representing the time complexity would be big O of n into m. And what will be the space complexity? The space complexity will also be same n into m because we are taking a 2D DP table of size n into m. And other than that, we are not taking care of and not requiring any extra space. So the space complexity is also this. So now let us do a dry run for the same approach. Okay. So okay. So in this case, we had our string. Let me just yeah. So this was our string. Our string was A B C J K L B and A C J K P. Okay. So the answer was C J K. So initially we will start with I equal to 1 and J equal to 1. So this is our DP table. Let us say that this is our DP table. So we are having n is equal to 1, 2, 3, 4, 5, 6, 7, and m is equal to 5. So 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so let me just draw the table very properly and then I hope it will be very clear. Okay, so this is the DP table. So initially we are filling all the values of the table to be equal to 0. Okay, so I'm not showing that right now because it will take some time to fill the table with 0. So just assume that all the values are filled with 0 initially. Okay, so now what is the operation? So right now we are standing on the I equal to 1, which is basically this particular index because we are checking index I minus 1 and j minus 1. So I minus 1 and j minus 1 will basically be equal to this index, and now they are equal. So when they are equal, what we were doing is equal to, we were finding a value. Value was equal to 1 plus dp of I minus 1 and j minus 1. So 1 plus value of dp of 0 comma 0 because I and j are equal to 1. So 1 plus dp of 0 comma 0 will be equal to 1. So dp of 0, 0 is basically already 0. So the answer of dp of 1, 1 will be equal to 1. Okay, so we calculated this value and we are putting. Okay, so how we'll proceed then? Yeah. So basically, what we'll do here is that yeah. So answer will be equal to 1. Now again we move to the next index. So basically I is equal to 1, but now j will move to that. So j is equal to 1 to m. So it will try to match these conditions. So answer will again become equal to 0. Okay. So dp of I comma j will be equal to 0. So this part will be equal to 0 because I is equal to 1 but j is equal to. This will again be equal to 0. This will again be equal to 0 and this will again be equal to 0. Now I will become 2. Okay. So now I will become 2. So we are checking with b. So again j will come as 1. So this will become equal to 0. Now 2 comma 2 is basically b comma c. It is again different. So it will again become 0. Okay. So b is also not matching with anyone. So it will all become 0 once again. And we are already having 0. Okay, so till now our answer is 1. Now finally we come to C, and for C, the value of I is equal to 3 and the value of J will be equal to 2 when we are having a match. So I is equal to 3 and J is equal to 2. So we will be writing 1 here because this will be 1 plus this particular value which is equal to 0. So once again we are trying to form a substring. Okay, so in this case all these value will be equal to 0. Now once we move to J, so what happens in J is equal to we will be able to put a value 2 here and we will be able to put a value 3 here, 5 comma 4. Okay, so cjk is basically, so as you can see at 3 4 and 5. So for I equal to 5, so for I equal to 5 and for j is equal to 4, we are having a value of 3. So 2 will be equal to 1 plus 1, 2, 3 will be equal to 1 plus 2, 3, and all this value will be equal to 0. Okay, so after that, the maximum value of answer that we can have is equal to 3. So therefore, the answer is equal to 3. Okay, so I hope this part is understandable. So I hope this part is understandable. Okay, so Divakar, can I please have a +1 in the chat box? So if you have understood this concept, so then I can move to the next topic. Yeah, so if not Devakar, so anyone who have properly understood the concept, can you please do a +1 in the chat box to confirm so that I can move to the next question? Okay, so if not Devakar, so anyone who have properly understood the concept, can you please do a +1 in the chat box to confirm so that I can move to the next question? Okay, yeah, Devakar is there. Thank you, Devakar. So Devakar, I see that you have also a small introduction about this session. We are having a practice to 1 or 2 problems on a regular basis. So this week we are having dynamic programming, and this will continue for the next 3-4 weeks or so, because dynamic programming is an extremely important topic from a lot of perspectives, and it a very frequently asked in interviews always. Okay, so I would request all of you all to kindly attend this session next week as well, and whenever we are having this session. Okay, so it will definitely help you in your interviews and in your preparation journey as well. Okay, so let's see what is the session today. So this is basically the problem on equal sum partition problem. Okay, so what exactly is this question? Let's see. So let us say that you are given a problem called, the name of the problem is subset sum equal to k. Okay, so name of the problem is subset sum equal to k. So you're given an array. Okay, now basically with n positive integer, so you're given an array with n positive integer. So let's say you're given 1, 2, 3, and 4. Now you are asked to need to find if there is a subset in array with the sum equal to k. Okay, so you have to find basically a subset. You have to make a subset from this array. Subset is basically you pick up any combination of elements from this array. For example, you can pick 1 and 4 or 2 and 3 such that the sum is equal to k. Okay, so let us say the target value is equal to 4. So if someone is asking you that whether it is possible to make a subset equal to 4 or not, you can say yes, it is possible, because you can, let's say, you can make a subset by choosing 1 comma 3, because sum would be equal to 4, or you can just choose the value 4. So in that case also the sum will be equal to 4. So basically so why a greedy solution doesn't work? Okay, so why a greedy solution doesn't work on this problem? Okay, so why exactly we need to apply a DP solution? Why a greedy solution will not work on this problem? Can anyone tell me? So basically, in my first session, I have told you that greedy solution basically works on some sort of intuition or a common sense. Okay, but and a dynamic programming solution works if we are about to generate all possible answer. So basically, let's say in scenarios where we have to generate all possible answer and then choose the best one out of those. In that case, we have to apply DP solution, because we are not applying any sort of intuition or a common sense to derive our solution. So let us say that we generate all possible subsets. Okay, so if we have an array of size n, then can anyone tell me how many subsets can we have? How many non-empty subsets can we have? Anyone? Devaka, do you know the answer? If we have an array of size n, how many non-empty subsets can we have? So what we are basically doing is that we are generating all possible subsets and then checking that if the sum is equal to target or not. Sum is equal to target or not. Okay. In that case, what will happen? That sum is equal to target or not. Okay. So if the target is there, in that case we can simply return true. Otherwise, if even if we generate all possible subsets and we are unable to find the value of sum to be equal to target, in that case we will return false. Okay. So we have to devise a particular recursive solution to solve this problem. So let us have a look. Okay. So we will be having bool f. Okay. So the function will be bool because we are just returning true and false. So in that case, we will be writing int index. Okay. And then we will also be writing int target. Okay. And we are also taking the vector error as well and the dp table as well. Okay, so now there are two conditions. So whenever we have an array and we have an element we can either pick the element or we do not pick the element. Okay, so these are the two conditions that we can particularly have. And when we were dealing with the topic of recursion, in that case we also studied this particular thing. Okay, so let us say that bool not taken. Okay, if I'm not picking up the element, in that case what I can do, I can recursively call the function, and then I will pass the value of index minus 1 because we are starting from the very last index. We'll call index minus 1. The target will still remain same because we haven't picked up any elements, and the rest of the value will be same. Okay, now let us say that I have picked the element. Okay, so in that case what I will say, I will just write bool taken is equal to, let's say, false, and then I will recursively call for the function. But before that, I will check that whether the value of the index that we are picking is less than or equal to target or not. If it is less than equal to target, then only we can pick the element, otherwise the target will become negative. Okay, so in that case what we will write, taken is equal to f of index minus 1 comma target minus arr of int. Okay, so that is the reason we are checking this condition, because if this condition is true, then only we can proceed further, otherwise this value will become negative. Otherwise this value will become negative. So in that case what we will do, basically we have a this value will become negative. Okay, and then what we will do basically is that if we basically need to take care that we have gotten one true, so we will just make sure taken or not taken. Hmm. Okay, so in that case what will happen, yeah, and we also need to make sure we will be checking basically. So after that, what we will be doing, we will be having this particular value int. So if we will be checking that whether dp of I and j is equal to is not equal to minus one. If it is not equal to minus one, in that case, what will happen? We will return dp of int target. Okay. So that is the optimization part of this problem. Okay. So I hope everyone understood this kind of concept. Okay. So Divakar, you are saying that the it will be factorial. Okay, no. So basically, if we have a subset of size n, in that case, the value of the number of so it will be 2 to the power n. So if we have a size of the array is equal to n, then the number of subsets we can generate is 2 to the power n. So, do you guys have any doubt in understanding this question? Can you kindly let me know? And apart from that, uh, yeah. So, apart from that, can you please tell me what exactly will be the time and space complexity of this? Yeah. So, anyone, can you please tell me about the time and space complexity of this? Okay, yeah. So the time and space complexity of this will be n into k because n is the total number of because n is the total number of elements in the array and k is the target we are trying to reach. Okay, so and the space complexity will be also n into k because we are taking a two-dimensional DP array, and at the same time we are having a value of k equal to the recursion stack space. Okay, so basically in that case that is how things will be. So I hope everyone understood it. So let me write the time and space complexity here. Hmm. Hmm. So time complexity will be big O of n into k and big O of n into k plus big O of k. So this will be the space complexity and this will be the time complexity. Okay, it would have been 2 to the power n if we would not have applied this optimization. Okay, in just brute force recursion it would be exponential. But if we're applying this optimization, in that case we will be having this particular case. Okay, so this is how things will be. Okay. Okay, so yeah. So do you have any doubt in this question? And yeah, so this is basically the recursive solution, and we will be implementing a tabulation solution as well. So that will be given to you as a homework, and we'll be meeting in the next week as well for the same topic of dynamic programming, and we will look into other concepts as well. Okay, so kindly let me know if you have anything to ask. Okay, so and there is also let me just give you one tell you about this course particularly called the complete interview preparation. And if you're preparing for your interviews, then this particular course will be extremely useful for you. Okay, because it contains all the important concepts and questions related to interviews which are very frequently asked, and at the same time it is extremely structured as well. So I am sure you will be able to find this particular course extremely helpful for your interview preparation. Okay, so then yeah, so I would request you all to kindly check out this course, and yeah, thank you very much. So see you next week then. So I hope Divakar I will be able to see you next week then. Bye bye, good night.